Hello and welcome to your post-practical lecture for Experiment 1, which was focusing on thermochemistry. Essentially, in the post-practical lectures, we will always look at the report writing aspect. So once you've gone through all the experimental work, what are we expecting of you to write a report and the data analysis of the report to guide you, to help you, to give you some extra advice, and to help you with, to assist you with the calculation part of your report. So in the report for experiment 1, we of course looked at thermochemistry and we looked at two parts. Firstly, neutralization reactions, acid-base reactions, and then we also looked at dissociation reactions of salts. So remember, you have to have those two concepts distinctively in your mind, but you need to combine them under the umbrella concept of thermochemistry. So continually have that as the broad concept for your report, with the latter split into the smaller subsection experiments, right? Also, building on that, what you specifically need to have in the report is a title page. Now, a title page doesn't necessarily mean it has to be a page on its own. You can have your title page with your name, your student number, all your details, etc. And then, of course, your title. And of course, your title doesn't need to have something that says title, and then you have your title. You just have the title of your report. But we'll get to that in a minute. And then, of course, we need to have an abstract, an introduction, results section, discussion questions that you need to answer, and some references. And we'll look at each of these sections now individually in this lecture. So, firstly, your title. You can use the departmental report writing guide we provide for you on ClickUp to look at all the sections, and the general concept of report writing is discussed in there quite broadly. But because I do understand there's a lot of information provided in this guide, this is sort of a summative idea of what is required in your report. Okay. So as I said, remember, we looked at thermochemistry here split into two ideas of neutralization and dissociation. And in your title, you need to combine this so that and under 15 words, so that we understand that both of these aspects were looked at under the umbrella concept of thermochemistry. And using what kind of technique? So calorimetry, right? And what kind of specific kind of calorimetry. So play around with these ideas. For example, a calorimetric study of the constant volume or constant pressure calorimetry of. These are all sorts of ideas you can come up with to create your title. And like I said, just be creative and don't copy from the practical guide. The practical guides titles are really ambiguous, and I try to keep them as plain as possible to give you the freedom to come up with your own titles as much as possible, because otherwise I take away some of the options that you have. So these are my guidelines. Think of a title that is going to give the main idea with some specifics in less than 15 words. So it's not a strict rule. If you have 17 words, no one is going to come to your house and beat you up. But 15 words is a good guideline. Remember, 15 words is a lot of information already. So use it as a guide and do not copy from the practical guide. Okay, so that's the title. And as I said previously, it can be on your title page, which contains all your information, or it can be on the next page, just as your title of your experiment. It does not have to have its own heading that says title, and then the title, it can simply be the title of it and say da, 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 and then the next title underneath that, or the next heading, is abstract, as we've already discussed when you did the word assignment on how to introduce new headings, etc. in your reports. All right, so the next heading you'll have in your report is the abstract. Now, the abstract is generally about 2 to 3 paragraphs, and you'll see how these 2 to 3 paragraphs unfold in a second. An abstract is sort of like a summative idea of what your report was about. If you were a very lazy person and you read the abstract of someone's work, That must give you an idea if it were worth to read the rest of that report. Essentially, the summary or the abstract of someone's work is there to advertise the rest of the report. Essentially, you won't ever read a full article from the beginning. You'll read the abstract and see if it fits into something that you are interested in, and then only will you read the rest of the work. So in other words, have that in mind while writing your abstract. Now, that said, what must be in this abstract? I always like to start with a sentence introducing the field and stating the main aim. So not one sentence, but a sentence introducing the field, and then I state the aim of the experiment. For example, my research field is in the field of perovskites, which is the solar cell application. So I would say something like, the field of perovskites have recently seen an inundation of new research due to their popularity in solar cell research among other fields like this and this and this and this. In our work, we will look at solar cells and this, or the application of perovskites in solar cells. So now I've introduced the field and I've stated the aim of the experiment. So you'll introduce thermochemistry and you'll discuss what the aim of our experiment specifically is. Remember, we had two distinct aims of the experiment. So you'll have two sentences explaining what the aims were. Right. You also need to give the main results of your experiments. In other words, literally giving the results. So you will say, we obtained the heats of neutralization of sodium hydroxide with HCl, which was found to be this, and of sodium hydroxide with something else, and with something else, as well as the dissociations of these salts. And you do not do them in table format, you don't put it like that, you put them in words. I say paragraphs. Please do it in paragraph form. This is a paragraph, and you do it summatively. Right. So what do we have this for? You've introduced the field, you stated the aim, you've given people the main results. But you also give them the negatives of your result. You say where you might have gone wrong, what happened, maybe a sentence or two regarding things that you did wrong, but also like how are you going to fix them? And then where can you better them for future experimentation? So that should give someone a very broad idea after they've read this of exactly where are you coming from, what did you do, and where are we going? Understand? So that's why it's a summary of your report. It summarizes all the sections that you will ever do in a report in 2 to 3 paragraphs. And like I say, 2 to 3, so it depends on how much you need to write for the specific report. Depends on like how many paragraphs this will be. Okay, so I hope this gives you some ideas of what needs to be in your abstract. Next, in your introduction section for this report, you need to remember the introduction section is really, as it says, you need to introduce the reader to this experimental field. And this you do by explaining again the aim of the experiment, and you can also give the relevant background. So aim, you first say we want to do this, and then background, why do we want to do this? Of course, you can also cover relevant theories. In other words, equations that might be used. Do not just copy from my prac guide, my beautiful prac guide. And you can discuss anything that you feel is relevant there theory-wise. In other words, any equations, anything that you feel a reader might need to understand your report. Essentially, after this, a reader should be equipped with the foundation to understand anything that follows from there. So, but you also need to remember your reader is someone that is knowledgeable in the field of chemistry and sort of knowledgeable in the world of science in general. So you don't have to explain basic scientific notation or like what is a graph or what is a formula. You don't have to go that plain, but just a general idea of maybe something that you had to read up on before you wrote it. It's generally a good idea to include in the introduction. And like I say, you don't need to write the textbook. It's just about a page of your aim, why are we doing this, and then some theory regarding that. And be creative. Always. Creativity makes the world go round. Otherwise, you just fall asleep. Okay, your results section. Now, I'm first going to give a general discussion on what a results section entails, and then we'll go into specific discussions of parts 1 and 2, how to analyze your data and get to the specific values, etc., how to use the equations and whatnot. Now, in the results section, you can use the theory developed in the Pratt Guide always to calculate any relative quantity. So if you need to calculate something, there is bound to be an equation to calculate that quantity somewhere in the Pratt Guide. That's a general rule you can follow for the rest of this course. Okay. Of course, remember always to just keep track of what exactly your symbols mean. For example, there's ice, water, and there's initial temperature. And if both of these things, temperature is labeled Ti, that's going to be very confusing. I mean, I get confused. And I have like 3 degrees in chemistry, so I might advise you to go in another direction. So just be aware of those kinds of things. And then, of course, always just make sure that any calculations that you do in your results section make sense. For example, no negative heat capacities, or if a temperature drop, so in other words, if a reaction has to absorb heat, will your enthalpy be larger or less than 0? So in other words, constantly be criticizing or be critical of your results that you obtain. So that's your general guidelines for results. And in general, your results is what it is. It's your results. It's tables of your results listed in, tables of your results. It's essentially what it is. It's all your data points listed in tables with the calculations given to us in what it is. So in the template, you'll see there is some guidance as to there's tables, and then there is saying there's some place for you to say to calculate your relevant quantities or what we require you to calculate. So follow the template, and of course always make the template quite nice. Don't just use it as is. All right. So the specifics regarding your results section. In part 1, so let's start with part 1. Remember, we looked at the heat of neutralization of 3 acid-base reactions. So just as a general concept, the heat of neutralization of these reactions will be equal to the heat capacity times the temperature difference. So the heat capacity of the calorimeter at constant pressure times the temperature difference that you measured. Right? So simple as that. That's our end goal. That's what we want. So we want Cp and we want delta T to calculate Hn. Okay. And we did that for sodium hydroxide with 3 different acids. That is essentially what we did. Now, first we needed to calculate Cp. That was experiment 1.1, of course. So that is where you use equation 1.9 in your Pratt Guide. There, I'll give it again. So I say V ice water, Tf, Ti, Tc, Tf. And here you see some confusion can come in with the notation. So focusing on our notation and some confusion that there might be. So Tf is final temperature. Ti here is the initial temperature, but of ice water. So the ice water's temperature, not just the initial temperature of the system of the ice water. So that part where you stick the thermometer in the 100 milliliter measuring cylinder, that temperature. And then Tc is the temperature of the calorimeter's content. So in principle, this is the initial temperature of the calorimeter, if you take it like that. Okay. So if you did not follow that, here is your table. So remember, in your fill-in sheet, this is what you saw. So if you look at that, Tc is these values, all these values, because you're going to carry this one over to there, and you'll carry this one over to there. That's your Tc values. Next, your Ti values are the ones that you put in there, the ones from the measuring cylinder, your ice water temperature. And then Your final temperatures is the one after you've allowed the system to equilibrate. That will be your final temperatures. Okay, I hope this gives you a very good idea of exactly where to find these values and where to plug them in to equation 1.9. That then gives us our heat capacity. But so to use equation 1.6, which was Cp delta T, we still need delta T. So to calculate delta T, we need a T final and a T initial. The T final, or the T initial, is of course the calorimeter's initial temperature. So the initial temperature of the contents. So the Tc of equation 1.9 is the Ti you use in equation 1.6, or essentially the values that come in these blocks. And our T final is the same T final as we use in equation 1.9. That then gives us the heat of neutralization. Okay. My last thing that I want you to think about is just remember, what is a positive or negative value for heat of neutralization? What does that mean? Exothermic, endothermic. That is your discussion. Does, which one implies which? And that you won't necessarily discuss in the results section, but keep it in mind that what do you expect? What did you see? So if you saw a temperature increase here and you get a positive value, let's say for delta H, does that make sense? Do these two things correlate? Do we expect a negative value for delta H? What is delta H a measure of? That's a very subtle argument. And if you're unsure, you need to revise your first year notes. Or if you're lucky enough to do this section or this experiment along with theme 2, which is the first law of thermodynamics, you should be able to argue the argument or argue it quite logically. Otherwise, just look up what is delta H supposed to be for a exothermic reaction, what is it supposed to be for an endothermic reaction. Right, so the specifics for part 2. Remember in part 2, we looked at the dissolution of a solid to aqueous conditions. In other words, AB to A and B in aqueous conditions. And essentially to start off this part, we again determine first the heat capacity of our calorimeter. And the reason we do it is we need to determine it for the specific method again, and if there were any changes during the whole experimentation, because we've done a lot to the system since we started the day. So for that, we're going to use equation 1.2, right, where Q is the heat of dissolution per mole of ammonium nitrate, which we give to you on page 19. M is the mass of the salt, which we also give to you, molar mass of ammonium nitrate, which we also give to you, and delta T is what you measured, right? Quite sure you'll be able to figure out what delta T is, and then you plug it in there, and then you have the heat capacity. Now the question is, should this heat capacity be similar or completely different to the previous heat capacity that you determined for the system? Now, in principle, the answer should be yes. It should be actually exactly the same. But, stuff happens. So maybe you can figure out why stuff happens. All right. Then using our newly calculated heat capacity, you're going to look at the heat of dissolution for 2 other salts, copper sulfate pentahydrate and barium chloride dihydrate. And you use equation 1.13 for that. So again, heat of dissolution is equal to this, and with these parameters. So your initial value for your delta T is equal to T final minus T initial. And then your T final values are the ones in this part of the table. So again, there, and T final are these 2 values. Of course, you calculate every time for a specific determination. So you have a Q for determination 1 and you have a Q for the determination 2. I didn't specify it previously, but please don't plug in everything. You will have a determination 1 Q or a determination 1 capacitance, and you have a determination 2 capacitance. You have a determination 1 heat of neutralization, 2 heat of neutralization, 1 heat, 2 heat. You get the idea, and then you take an average at the end. Right. Okay, and once you plug that in there, you have the molar mass, you have the mass, you have your system's heat capacity because you just calculated it, and then you get the heat of the solution for each of these two salts. Right. Finally, just talking about the discussion questions, you need to, we look at part 1's discussion questions. So what will the value of delta H be for the reaction between dilute nitric acid and dilute sodium hydroxide? My hint here is, so we've looked at sodium hydroxide and a strong acid, HCl. We looked at sodium hydroxide and a strong acid in a 1:2 ratio, where it's sulfuric acid, H2SO4. And we've also looked at the reaction 1:1 reaction of sodium hydroxide with acetic acid. So you need to figure out what will dilute nitric acid, which one it is similar to, and then build your argument upon that. Is delta H a neutralization reaction dependent on the concentrations of the electrolytes? That essentially you can think about that in terms of the equations itself. And actually, just does it make sense that your delta H is dependent on the concentrations? Or look at the units of delta H itself. So look at the equations, look at the units of delta H of neutralization. And then for part 2, how does the heat capacity determined in this experiment compare with that determined in part 1? I sort of already discussed this question. You need to determine it for yours specifically. How well does yours match? Discuss what you've got and discuss if you see any discrepancies, any similarities. Go wild. Finally, in your reference section, so we've covered how to reference and using Mendeley and using the RSC method, the Royal Society of Chemistry's citation style. Please remember to use that citation style. If you are not using Mendeley, then remember to follow the examples given in your prac guide on how to reference different sources. Of course, remember to give credit where you found anything. So even if you just looked up something stupid, sometimes it feels like you just looked up literally how to calculate something or just watch the YouTube video or whatever. That's technically something that you need to reference. Don't really reference every little detail that you looked up, but anything that you really used, something that you really definitely spent time looking up, researching, and then found very useful in writing in your report. Please give credit to those authors. You do not really need to reference the prac guide unless you feel it was really helpful and you want to reference myself, then you are more than welcome to reference me. Of course, use Reaccess and the library in general to find yourself some real scientific resources, especially if you're looking up, if you want to see if your heats of neutralization or your heats of dissociation, you can find articles relating these heat values. You can use Reaccess. Remember, Reaccess can search general terms or chemistry terms. So if you put in heat of neutralization of sodium hydroxide with whatever, and you should find something. I mean, it is one thing, or you can just Google it. That's also fine. I don't know, but I'll sleep better at night if you use Reaccess. Okay, now, essentially, good luck. And as always, any questions, you're more than welcome to ask your demonstrators. You have the email addresses as well as myself. So good luck and thank you for watching.